What's good? So this video is for Descartes' rule of signs. Once again, this is not about solving the problem. This is more of an analysis question. So we got this function right here. It's a huge polynomial. And first thing I just want to make sure you guys all remember is that the degree of the polynomial, that 6 right there, tells you the number of the number of solutions that this polynomial will have. So we know that this polynomial will have 6 solutions. Now we have to be careful. It doesn't mean that there are 6 unique solutions. So there is a chance that the answer it's like 1 6 times, right? That can happen. That's not what's happening here, but that's a possibility. So this right here, the degree of the polynomial is 6. So we know that there are 6 solutions. It's not at least 6, it's exactly 6. But some of them can repeat themselves. So sometimes it's not obvious that there are 6. Like some people are like, but I only found 5. Yeah, but one of them repeated itself. Or I only found 1, but yeah, one of them repeated itself. Now, why is that important? The fundamental theorem of algebra really lets you know like when you can stop looking for solutions. Let's say you found 6 solutions. You're like, geez, when am I ever going to find the 7th one? Well, you're not, because the degree dictates or indicates how many solutions you're going to have. Okay, so that's the first part that you need to understand before you can apply Descartes' rule of signs. Now we're going to look at what Descartes' rule of signs actually says. It states that the number of sign changes between each term will indicate how many possible real solutions you can have of a certain type. When you analyze the function as it is right now, you'll notice that we went from a positive 3 to a negative 11 between the 6th and 5th degree term. And then between the 5th and the 4th degree, there's no sign change there. It stays negative to negative. But between the 4th and the 3rd, you have a sign change. Between the 3rd and the 2nd, you have another sign change. Between the 2nd and the 1st, you have a sign change. And between the 1st degree and the constant term, you have a sign change. So what this tells us is that we have, count them, 1, 2, 3, 4, 5 sign changes when in the original function. What this tells us is that there are a possibility of possible positive real roots that can be up to 5. So 5 is the limit. You can't have more than 5. But Descartes found out that not only is it 5, but you can actually have 2 less than that, to 3. So we can either have 5 positive real roots or 3 positive real roots. Now we obviously can't have 7, right? Because it's a 6th degree polynomial. But 5 is the limit for the positives. You can have 2 less than that, which is 3. And you can have 2 less than that, which is 1. But it is impossible to have 2 less than 1, because that would give you a negative number of roots. So we're just going to say 5, 3, 1. Those are the possibilities. Now remember, there's 6 solutions. So if there's 5 positive reals, like what are the other possibilities? And this is where Descartes' second part to his rule comes into play. If you take the function and you put a negative x in place of all the x's, what you end up getting is a secondary function you can analyze. Now I'm going to go ahead and simplify it. So if you put in 3 to the power of negative negative x to the power of 6, that just simplifies out to 3x to the 6th. So I'm just going to write 3x to the 6th minus 11x, not x, negative x to the 5th. But the thing about negative x to the power of 5 is that when you multiply it out, it comes out to negative. So you get negative times negative 11, which gives you positive 11. So I'm just going to go back and change that one. After you do all the substitution of the negative x's, what ends up happening, all the positive even valued functions or even valued terms, they don't change. That's going to stay negative 75x to the 4th. But all your odd degreed terms, those are going to change. So that one there is going to go to negative 225 x to the 3rd. This one here, which is an even degree, is going to stay negative 198 x squared. And this one here, which is an odd degree, is going to change from positive to negative 236 x. And the negative 120 won't change because it's constant, which means it will never change. And then once again, we analyze all the sign changes. Now you'll notice that between the 6th and the 5th term, there's no sign change. But between the 5th and the 4th, there is. And that's about it. There's exactly 1 sign change here. 1, count them. Now what this tells us is that the number of negative real solutions is going to be 1. So we're going to have 1 negative real solution. The good news is we know we're going to have real solutions. We know we're going to have positive ones. We know we're going to have we're going to have exactly one negative one. The question is what are all the solutions going to be? And this is where we analyze Descartes' rule of signs. So this is Descartes' rule of signs broken down. Now comes the analysis. Using the fundamental theorem, we know that we need to have a total of 6 roots. So we're going to be looking for 6 roots the entire time. Now, Descartes' rule of signs tells us that we can have positive roots. And our positive roots can go up to 5. We can have negative roots. Let me change that to black over there. We can have negative real roots. Oops, let me change that to red. Sorry, want to keep things color-coded. Real roots, but then there's also one more type of root. So we have the real positives, the real negatives, and then we have our complex roots, the imaginaries, the i's. These are all the possibilities for roots when it comes to polynomial functions. So we look at our first scenario. Our first scenario is to have 5 positive ones. Well, if we were to have 5 positive roots, there is one more root, because remember, it always needs to add up to 6 because of the degree of the polynomial. Well, we need to have 1 negative. So we know we're going to have 1. That right there adds up to 6, which means we know if that was to occur, we would have 0 complex roots. Now, 5 is not the only possibility. We could have also have 2 less than that. So we could have 3. Now, if we have 3 positive roots, we can have 1 negative, because that's what it tells us our possibilities are. Now, if there's 3 positive and 1 negative, that's not enough to make that 6 right there. And this is why we would have to have 2 complex roots. But using Descartes' rule of signs, 5 and 3 were not the only possibilities. 1 was also a possibility. So we could have 1 positive root. Now, if we have 1 positive root, we know we have to have 1 negative root, because that's what Descartes' second part of its rule of signs, his second part of rule of signs said. But if we have 1 positive and 1 negative, that means we're missing 4 more roots. This is where the complex roots come into play, and we can have 4 complex roots. And this is how Descartes' rule of signs works. If you have any questions, go ahead and hit me up, and I'll get back to you as soon as possible. Best of luck with it.